Hello and welcome to another session in mathematics. In this session we'll be looking at operations of sets. But before that, let us look at the previous lesson. Welcome back. So our topic today is operations of sets, and our purpose is to continue the definition of terms and notations here in sets. Okay, so let us start with the word subset. What does the word subset mean? The subsets of a set A are the other sets that can be formed from what? Set A. The other sets that can be formed from set A, we call them what? Subsets. For instance, we have a set A to be equal to set of 1, 2, 3 and 4. 1, 2, 3 and 4, and you see we form them other sets from this set A. We have set X, we have set Y, we have set Z, and we have set P. We also have set Q. And you will agree with me that this is an empty set. Is that correct? And then this also is the main set. Okay, so every set is a subset of itself. Okay, note that every set is a subset of itself. I want you to note that. So that's why we have A to be equal to 1, 2, 3, 4, and here we have P also to be equal to 1, 2, 3, 4. Okay, now I want you to also note that empty set is also a subset of every set. Once you are asked to find a subset of a given set, you also start with immediately you write the original set, also write what? The null set, which is the empty set. Okay, then let's quickly look at what we call the proper subset and the super subset. Proper and super subset. Okay, when the whole set is left out, the remaining subset are called proper subset. Proper subset. What do we mean? When you remove this, every other set that remains is what we call what? The proper subset and super subset. Okay, like we have set X, we have set Y, we have set Z, and we have set what? Q. All these ones are what? Super subset and proper subset. That's why we say that we have X, Y, Z, and Q. They are called what? The proper subsets of what? The set A. Okay, then let's quickly look at the improper subset. Improper subset is the whole set which we brought out when we started. I told us that every set is the subset of itself. Now the set you brought out to be the subset, which is the original set, is what we call the improper subset. That's why we said when the whole set is involved, then it is improper subset. So P is an improper subset of A. In this example, we are giving A to be the set of 1, 2, 3, 4, and also we gave P to be a subset, and we said that P is equal to 1, 2, 3, 4, and which I explained earlier that every set is a subset of itself. So P is a subset of A, and as such we say that P is an improper subset. It's an improper subset. Okay, normally it's not supposed to be a subset, but that is the way it is being counted. So every set is a subset of its own. So that is how we got this to be what? A subset, and it's called what? An improper subset. Next we have what we call the power set. The power set. The power set helps us to understand the number of elements or subsets in a set. It helps us to identify the number of subsets of a set. Mark that this power set is what helps us determine the number of subsets of a given set. For instance, if we are given a set containing one element, like here on the screen we have A to be equal to set of 5. It contains what? Just 5. So if I ask to find the subset of this A, which is 5, the first thing we need to write is what? 5. I told us that every set is a subset of itself. Now this is a subset, the first subset, and let's call it A. And then B will be what? Empty set, because I told us also that empty set is a set of what? Is a subset of what? Every set. So we have the subsets to be A and what? B, and therefore set A has what? 2 subsets. Now I want to tell us that when we want to determine the number of subsets in a given set, all we need to do is to find out the number of elements in that set. Okay, when we find the number of elements in that set, then raise 2 to power of the number of elements in the set. So we are giving that to be equal to 2 raised to power what? N, where N is the number of what? Elements in a set. Okay, assuming we have A to be equal to the set of 1, 2, 3. To determine the number of subsets that should be here, what you do is to write down your 2. How many numbers are here? How many members? We have 1, 2, 3. So you write 2 raised to power 3, and 2 raised to power 3 is what? 8. So it means that set A should have what? How many subsets? 8 subsets. Is that true? Let us check if it is correct. Let's call the first subset A, and it should be what? 1, 2, 3, which is a subset of the original set. And then we have the second one, the null set. Is that correct? That's number 2. Let's call it B. And for C, we have set of 1. For D, we have set 2. For E, we have set 3. For F, we have set 1, 2. Okay. For G, we have set 2, 3. Then for H, we have set 1, 3. And mark all this, there is no repetition of any kind. There's no repetition of any kind. Okay, so how many subsets do we have? We have 1, 2, 3, 4, 5, 6, 7, and 8. Do we understand? So for a set that has 4 elements, it will now be 2 raised to power what? 4, and that will give us what? 16. So a set that has 4 elements will have 16 subsets. A set that has 5 elements will have 2 raised to power 5, which will give us what? 32. So any set that has 5 elements will give us what? 32 subsets, and so on and so forth. Let us look at the universal sets. Universal sets. The universal set of A and B, written as A union B, are those elements in either A or B or both. What do we mean? That means the combination of the elements of sets A and B where no element is repeated. What are we saying? What are we saying? If we have set A to be equal to set of A, B, C, D, and we have B to be equal to the set of A, D, F, C, G, and we are asked to find A union B, all we are asked to do is to combine these two sets without what? Repetition of any letter. Okay, so let us start. We have A, this is A, this is A. We'll just write one A, no repetition. We have B, we'll write it down. We have C, and there is C here, we'll write one C. There is D, there is D, we'll write D. And another letter, yes, there is F, we'll write F. There is G, we'll write G. Another thing, A, B, C, D, okay? Another thing, no. So A union B is just the combination of A and B without what? Repetition. The combination of A and B without what? Repetition. That's just what it means for us to have union of sets. Let's then go over to intersection of sets. Intersection of sets. Okay? Intersection of sets. The intersection of any two given sets, let's say A and B, is a set which contains all the elements which are common to A and B. That is speaking out the elements that are called in the two sets. If we have set B to be equal to the set of 1, 3, 5, 7, 9, and we have our C to be equal to the set of 2, 3, 7, 9, 11. The intersection of B and C, written as B and C, is equal to the set of the numbers that appeared here and also appeared here. Okay, intersection means what? Something they have in common. 1 is here, there is no 1 here. 3 is here, there is 3 here, so we write down 3. 5 is here, there is no 5 here. 7 is here and there is 7 here. That is the second intersection. There is 9 here and there is 9 here, we write down 9. There is 11, there is no 11 here. Our B intersection C is equal to the set of what? 3, 7, 9. So having studied the terms and the annotations in sets, kindly provide the answers to the following questions. Welcome back. We'll stop here for today. So far we've been able to cover annotations and terms in set theory, and we've been able to look at intersection of sets, we've been able to look at union of sets, we've been able to look at subsets, and so on and so forth. So do well to use the lesson note on the platform for better information on the topic we've discussed so far, and feel free to drop your questions or comments on this comment section. In our next class we'll continue. Till then, take care and stay safe.